we look at this graph and we want to find the rise over the run, all we have to do is find 2 points on the line. So 1 point on the line would be this one here, right? Another point on the line would be that one. Or I could use this one and that one. Or I can use this one and that one. Or I could come down and use this one and that one. It doesn't matter. Any 2 points that are on the line will work. So let's say we use this point here and that point there. Alright, so the 2 ones I marked in purple. So we're going to do the rise. So the rise is how much do we go up from one point to the other. So from the bottom point to the top one, I'm going up 1, 2, 3, 4, 5, 6 units, right? So my rise is 6. Then my run, from this point, I'm going 1, 2 units. So that has a run of 2, which means my slope is 6 over 2. 6 divided by 2 is 3. So this has a slope of 3. Now, if I had used this point instead of the top one, if I'd done this point and this point, then I would have a rise of 1, 2, 3, and a run of 1. And guess what? 3 over 1 is also 3, right? So it doesn't matter which 2 points you pick. Once you simplify, your slope is going to come out to be the same, okay? For every 3 units we go up, we go 1 unit over. 3 units up, 1 unit over, which means if I go 6 up, I go 2 over. If I go 9 up, I go 3 over, okay? It's a proportion, and if we're going up 3, we're going over 1. If I double how much I'm going up, I double how much I'm going over. If I quadruple how much I go up, I quadruple what I go over. Okay, so, all right. So our answer for that one would be B, which is 3. Let's look at the next one. So for this one, let's see. Alright, so here we have this X and Y axis, and now we have a couple points that are on this line. We have this point, guys. I'm not amused. And then we have this point. And then they also give us, see, this point's also on the line, and that point. So we have a lot of different points we can choose from here. Now, the first thing, though, that I want you to do is determine what kind of slope does this have. So remember, left hand, put it on the left part of the graph, and you are going down. So this has a negative slope, which, when you have a multiple choice option like we do here, means you can look at that and I can say, which ones is it definitely not?
Positive. A and B.
A and B, right? Because A and B are positive. So I automatically know, hey, my answer is going to be either C or D. Now, I have to look at the line and determine my rise over run. Again, make sure you know rise over run. Don't mix it up and put the rise on top, the run on bottom. It's always how much you go up or down, over, left to right. So up, left to right. So our rise in this case. So let's pick 2 points. So let's say I pick this point right here. And that one there.
Yes, yes, yes.
Now it doesn't matter. I could use this one and this one. I could use this one and that one. I could use this one and that one. I can use those two. I can use those two. Any points as long as they are on the line will work. So I'm going to use those two though, which means I have a rise of, let's see, I'm going 1, 2, 3, 4, 5, 6. Okay, so that's 6 units down, and 6 units down is where the negative comes in, right? Remember, it has a negative slope, so that's where our negative comes from because we're actually going down instead of up. Okay, and then our run is 1, 2, 3. So my rise is -6, my run is 3, and -6 divided by 3 is -2. So my slope is -2. Now again, if you didn't catch, if you just were counting and didn't really pay attention to direction that you were going down and didn't realize that it was -6, if you just did 6 over 3 and got 2, then that's where it's important that the first thing we did was determine that it should be negative, because that tells me, oh hey, even though I got 2, it really should be -2 because it was going down. Okay, so,
That's what I did at first.
Why is it not 1/2? Because the rise is 6 and the run is 3. And it's rise over run. If you did 3 over 6, then you're doing run over rise, which is not what slope is. Alright, let's look at the 2 on the back. Ah, that didn't work real well. What? Alright, so this one we have some points on the line. I have this one here. 1, 3 is on the line. 2, 2 is on the line. 3, 1 is on the line. Alright, so once again, lots of points to choose from. Alright, now, I can use any 2 points on the line to determine my slope, but before we do that, the first thing I need to answer is what? Negative or positive. So, left hand on the left-hand side, and I am going down. So that means it is negative. Then, we count how negative now. I've been just picking any 2 points. Now, really, the easiest way to do it is pick 2 points that are close to each other. That way you don't have as much chance of mistaking counting. So really, the preference is to pick 2 that are close. You can use any, but if I use, say, this point and this point, then it's an easy to count because I'm going down 1. So my rise is
2.
My rise is what there? Okay, 1. Actually, it's really technically -1 because we're going down. And then my run is +1. To the right is positive. Up and to the right are the positive directions on your X and Y axis. Down and to the left are negative directions. So this is -1 over 1. But remember, all that really matters is that you know that your final result is going to be negative. So -1 means, and then -1 divided by 1 is -1. So this has a slope of -1. Alright, let's look at number 2 on this one.
I just walked to my grave and I just got chills all at my vest. Okay, that way you get chills if you let somebody walk up your grave.
Alright, so, alright, this one we have this point, and we have 3, 2. Alright, now this one, guys, number 2 on the back. Alright, now this one here is a little different in that how many points are there that are clearly on the line? It's on your paper. Alright, there are only 2 points that are really clearly on the line in this drawing. Okay? All the others kind of cross between lines, like they don't meet. Remember, to be on the line, it needs to be exactly where an X and a Y line meet up. So like here's a point, here's a point. But like this right here is slightly above. So it's like +1, but then it's not quite -1. So that's not on the line. That's not on the line. That's not on the line. So this is on the line and this is on the line. So those are the 2 we're going to want to use. My slope for this one is going to be positive, right? From left to right. Put your left hand on, follow it, and you are going in the positive direction. So this one is positive, and then to get our slope, we're going to take 1 point and we're going to go up 1, 2, 3, 4. So my rise is 4, and my run, I go over 1, 2, 3. So it has a run of 3, and since it's positive, that means the slope of this line is 4/3. You do not need to make it into a mixed number. You leave your slope. Because slope is rise over run, we really, if it doesn't simplify into a whole number, we just leave it as a fraction. So 4/3. No, that would be a mixed number. Okay, so if it doesn't come out to be an even whole number, because 4 is not divisible by 3, then we just leave it as a fraction, even though it's improper. So the slope of this line would be 4/3. Now, let's look at the front again. And this time we're going to be doing something a little bit different. This time we're going to be finding a line given the slope and a point that is on the line. So, this is number 3 on the front. Alright, so this tells us that we have the point 1, -2, and that we have a slope of 2. Now, one thing that's very important here, a slope of 2 means 2 over 1. Okay, anytime you have a whole number, it can be written as over 1, because 2 divided by 1 is 2, right? Anything divided by 1 is just itself. So anytime you have a whole number, you can put it over 1. That doesn't change anything. Austin, there's no reason you should have my stapler right now. Austin, do not get it. And really, that's stuff off my desk, which you're not supposed to be touching at all without permission.
Why do you have
Set it back on my desk. Don't put the staples in. Just leave it on my desk. And then sit down and take notes. Now, the first thing, Nick, that's unnecessary. The first thing we need to do is graph the first point. The slope is basically like directions. It's telling you how to get from one point to another, which means to start out with, you need that first point. Okay? If someone gave you directions, if I said, okay, directions to my house are, you take a right and then you go 3 blocks and then you take a left and then you go 2 more blocks, well, you would kind of need to know where you were starting from before you went those 3 blocks and took a right, right? I mean, the directions are different depending on where you're starting. So, the point is where we begin. So the first thing we're going to do is graph that point. So 1, -2. Who can tell me where I put 1, -2?
It's gonna be in the fourth quadrant.
It's going to be in quadrant 4. Sure, DQ, you can show me. Good. So 1, -2, we go to the right one. Remember, always left or right first. So +1, -2, so down 2. So there's my point. Now, my slope is rise over run, which means the top number tells me that I'm going to rise 2. So from this point, I'm going to go up 1, 2, right? But I'm also going to run 1. So that puts me right here, right? Rise 2, run 1. Now, no. Now the last thing you should do is double check. My slope is 2. It is positive. Did the graph that I create have a positive slope?
Yes.
Yes. If I go from left to right, it's going up. Now, if my rise was -2, then I would go down 2 and run 1. Okay, always go to the right, and then the negative tells you whether you go up or down. But just to make it easier, always go to the right for your run, and then your rise can be up if it's positive, down if it's a negative. So your graph should look like this. So on number 3, on the front, you should have this graph down. Rulers are good to use, but if you don't have one handy, you can also just use, like, if you use another piece of paper and stick it beside it and kind of trace along it. All right, so let's look at the next one.
Is anybody else in here hot? Or is that just me? Because I'm like burning
It's
up.
just you. You're one who's wearing long sleeves, pants,
I
and
know.
boots.
And you're the one that has your hands in your shirt. Yeah.
Okay.
This is what I do. This is what I do.
Really?
Really? Really, Tyler?
It doesn't work. Cold in here? It does. No, it's cold?
Girl, I'll rip it.
I'm not cold.
Because you wearing all that stuff.
You rip your shirts all the time.
All right. So for this one, guys, we're given that the slope is -1. Now remember, if it's a whole number, -1, we're going to put it over 1. Okay? And then it also is going to go through the point to 0. Now, for some reason, the ones that have zeros in them throw a lot of people off. Make sure you graph to 0, not 0, 2.
Wait, what?
A lot of people have trouble graphing points if they have a 0 in them for some reason. Make sure you're graphing the point to 0, not 0, 2. So, who can tell me where the point to 0 would be? Nick? You want to show me? On the 2 line.
Talk about you, man.
Yeah.
I feel so tall.
Go ahead.
Yeah.
Gabby's going to show me.
Alright.
Alright.
You're like, oh my god, I'm so tall.
Alright, so 2 units to the right and up or down. Remember, the Y tells us up or down, so we're not going up or down, so we're staying on the axis, but we're 2 to the right. So 2 to the right, up or down, none. So that gives us that point. Then we have a slope of -1 over 1, which means we rise -1. So I'm going to go down 1. and then we run 1, so positive, and that gives us our new point right here. Right, so a rise of -1, a run of +1. Connect those 2 points.
What?
Now, guys, the last thing, double check. My slope here that they gave us was -1, so it should be negative. Look at your graph. Does your graph have a negative slope? From left to right, we're going down. So yes, it does have a negative slope. Always do that last check, guys. I'm telling you, my advanced math class recently had a test on linear equations, and I'd say probably at least a third of the class missed a question because they graphed something with a positive slope that was supposed to have a negative slope or a negative slope. And I told them the same thing I told you. The last thing you should do before you say, "Oop, done with that one," is double check and make sure that if it has a negative slope, that it does in fact have a negative slope. And if it says positive slope, that it is in fact positive. I mean, it is checking whether it has a negative or positive slope is honestly something that I could teach my kindergartner to do. Okay? It's start on the left and look, up is positive, down is negative. But so many people just won't take the 2 seconds it takes to look at it, and then they'll get questions wrong because they say it's a negative when it's positive or positive when it's negative. Justin.
How do you know when to start that line?
How do I know when to what?
Start the line.
The line goes infinitely in both directions. So there is no starting the line. I mean, I just extended a little past those points in either direction. But technically, I mean, I could make this line go on that way, and I could make it go further. Is that what you're asking? So yeah, there's no like specific, oh, it needs to be exactly this long. You just want to make sure whatever points you actually graphed, that the line goes through them and then extends a little bit past them in each direction. All right. Let's look at the last 2 questions. Now these are actually really, really simple. 5 and 6 ask whether it shows a constant or a variable rate of change. Well, slope, guys, is the same thing as rate of change. If it's changing in the same way all the time, in other words, has a constant rate of change, then guess what else is going to be constant? It's slope, right? So look at number 5. Does the slope of that line look the same at any point?
Yes.
Yes. If you go from one point to another, the rise and run are going to be the same. If I go down 2, I go over 1. If I go down 2 more, I'll go over 1 more. Okay? Look at number 6. Is the slope of that going to be the same? No, I mean, look. I mean, if you look at the line, it looks something like this. I mean, look at this part of the line. What's the slope of this part like? Left to right, this is positive. Left to right, this is negative. I mean, this very clearly does not have a constant rate of change. I mean, it goes from a negative slope to a positive slope. Right here at the top, it's actually got what we call a zero slope where it's flat for a minute. I mean, this slope, and even in this part, it's curved, so it's not straight. So, you know, this part's a steeper line. This is less steep, less steep, less steep until it evens out and then starts getting steeper in the other direction. So, when it talks about constant rate of change, basically all you're looking for is it a straight line? If it's a straight line, then it has a constant rate of change because it slopes the same all throughout the line. If the line is curved at all at any point, or if you had a graph where the line went like this and then evened out and then like this, this also would not be a constant rate of change. It has a constant rate here, but a different rate here, and a constant rate here and a different rate there. So